We've learned a lot about quantum information. We've learned about randomness extractors, and now we're finally ready to distribute some keys. We will actually start with distributing keys using a very special classical channel. But after that, quantum key distribution should be easy for you. We will use many of the same ideas. So what exactly is key distribution? We have Alice and Bob, and they want to establish a key, for example, for use in the one-time pad. A key distribution protocol is a protocol between Alice and Bob. They exchange messages over the communication channel, such that at the end of the day, even if there is an all-powerful eavesdropper, they can produce keys. I will call the key of Alice Ka and the key of Bob Kb. We want these keys to have certain properties. First of all, Alice and Bob should have the same key. Or, since perfection is impossible to achieve in the real world, the protocol should be epsilon correct, in the sense that the probability that the key of Alice is different from Bob's key should be less than epsilon, where epsilon is a fixed parameter that we want to achieve. We also want that the key is epsilon secure. Namely, we want the state that is generated to be epsilon close to a state where Eve is ignorant about the key. Note that it's very easy to come up with a key distribution protocol that satisfies one of these two conditions. It is easy to come up with a protocol that is correct. Alice can just generate some random bits, send them over to Bob over the communication channel, and they both have the same key. But of course now Eve also knows the key. It is certainly not the case that Eve is ignorant. So we are correct, but not secure. It is also easy to come up with a protocol that is secure, but not correct. Alice can just, in the privacy of her own lab, produce a key and never send any communication of any kind to anyone, including Bob, and of course not to Eve. This is a protocol that is certainly secure, but it is not correct. So how can Alice and Bob accomplish key distribution? We've already said that Eve is all-powerful. She may have a quantum computer, a large quantum memory. She really has nothing else to do all day than to try and find out the keys of Alice and Bob. Alice and Bob certainly need some machinery to defend themselves. The first thing, which will be an assumption in all cryptographic protocols, is that Eve cannot look inside the lab of Alice and inside the lab of Bob. There's one portion of the world that Eve does not have access to. Note that it is impossible to construct any key distribution protocol if Eve has full access or significant access to the lab of Alice. In particular, she could just wait until they produce the key and then just take the key out of Alice's lab. The second resource that we want is that Alice and Bob can somehow communicate. As we've seen, it would be easy to construct a protocol that is secure, but not correct, even without communication. But to achieve both things, we need to send information. We will also assume that in the privacy of their own labs, Alice and Bob have access to some random number generator that I denote here as R and G. They can produce random bits whenever they feel like it. So what is this communication channel? We'll generally give Alice and Bob access to a classical authenticated channel. This is a channel across which they can send classical bits. Eve can read all the messages on the channel, but she cannot alter them or forge messages. In particular, it means that if Bob receives a message over this authenticated channel, then he can be absolutely sure that the message came from Alice. We will often just assume that they have such a channel for free, and we will discuss later on how they can produce one. We will start our exploration into key distribution by assuming in fact that Alice and Bob share a very special classical channel, where Eve can read some but not all of the messages. And finally, this is of course what we're aiming for, Alice and Bob will be connected by a quantum communication channel. A quantum communication channel allows Alice to send qubits to Bob, and Eve has full access to all of this quantum communication. She can read all the messages, she can alter them, she can do whatever she wants with this channel. Let's now take the first step towards distributing keys.